the basics and then what data mining is all about. And of course, a brief history about the data mining, how it started from the traditional data management systems to the main recent techniques that we are, which is big data mining today. So today, inshallah, we are going to complete the introduction topic, where we will discuss the two remaining parts, part 3 and part 4. Where part 3 is going to talk about the tasks and techniques of data mining, and part 4 is we are going to discuss some problems and challenges that you are facing data mining and what the way forward, where we can do a certain research to improve either the techniques or the approaches that we do, or even to improve the algorithms of doing the data mining, because there are a lot of works on the 5 line in doing that. So for part 3, which is the tasks and techniques of data mining, actually we are going to discuss the tasks and then even the applications of where data mining can be applied. So referring back to our lecture of last week, as we said, data mining is just a step of knowledge discovery in databases, where in some of the publications, textbooks, you see that data mining is being referred to KDD, that is knowledge discovery in databases. So these tasks and techniques actually are what make the data mining to be done, because whenever you want to do data mining on a particular data, definitely based on the problem identified, you have to also identify the kind of tasks that you are going to do in doing that data mining. So techniques actually help us to do the tasks. In the techniques, this is where we have the algorithms that we apply, that we use, that we can improve. We either adapt or. So by ensuring that the techniques is right, and then you are going to the right tasks. When you do the data mining, at the end of the day, you discover knowledge. And by discovering knowledge, then this knowledge can be used for decision making at the decision maker level. So technically, actually, you need to understand what tasks are associated to a particular task, because in every task actually has its own technique. So the techniques, understanding the technique which is associated to a particular task is one step of understanding how to do the data mining. For example, if you want to do the classification, let's say as a task, you want to classify data according to some variables. So you need to understand the kind of technique that you need to apply, which algorithm is appropriate for doing that particular, maybe 1 or 2 algorithms are appropriate. Then from there, you can test, you can compare. So, okay, now this is the best algorithm to apply. So when we talk about the tasks, we are talking of the activities that include classification, because we classify data, clustering, as we have seen during our lab session, which involve grouping the data based on the data distances, and then association rules, which are actually allowed us or help us to find the relationship between the data items. And then also the one important task is to do the prediction. So sometimes this task actually depends on what we have done using the classification or the clustering. There's another task to do the prediction, to predict what is going to happen. This is one of the difference between data mining and the traditional data management systems, where you are not proactive, they cannot predict. But data mining actually do predict for us, tell us based on the data variables, based on the available data that we have, then we can analyze it to do what is called the data analytics, then finally to predict what is going to happen, what is expected to happen based on that data. Then another task is the sequential analysis, where we look at the sequence of the data, like the DNA sequencing, then understand the flow of the data, and then come up with a solution with the knowledge from that. This is why the DNA, we call it DNA sequencing. So we'll see all the example of this. And then also deviation analysis in a situation where actually system, we try to understand the deviation from the normal flow or normal process as we discover frauds actually maybe in the banks or whatever. So that detection method actually try to detect the deviation from the normal process, how things are being done. This is why if someone's stolen your ATM card, try to use it with different passwords, actually by putting password maybe 1, 2, 3 times wrongly, then the card is going to be blocked because that particular system of the bank actually understand a particular deviation from the normal procedure, because inputting the right password actually is a normal procedure. So by suspecting an anomaly in keying in the wrong password, then this is what we call a deviation. So this is kind of analysis that the system we do as a data mine, all that other data mining, because it uses data to detect what is abnormal. And then also similarity analysis, which is similar to the clustering. So in clustering, we use similarity methods to find out the similarity between the data points and then come up with the solution. And then also trend analysis. Trend analysis is a task also that is associated with data mining to understand the trend of the data. So by looking at the data, maybe the charts or whatever, you can see, oh, how this data is moving. For example, now the temperature is being taken every minute or every second. So you can understand the trend. So this time around, maybe it's the summertime. So this is a trend. How the data is being captured. So looking at the data, then you can understand the trend. So data mining can help us to do this particular task, understanding the trend. And then this is what actually some brokers are using, actually, especially those that are into those businesses. They always understand, or sit down on their system, look at the trend, how the movement of the businesses is moving. Then from there they can take appropriate decision so that they can get more profit. This is the trend analysis. So this is another type of the data mining. So as I said earlier, actually each of the tags here had to be associated with one or two or more techniques that can be applied to do that particular task. By doing the task, then you mine the data. So some of the tasks that we are going to be discussing maybe in the course of our lectures is the decision trees, which are the algorithms. I think we have even seen them under the classification algorithms. And then association rule, the algorithms that can be used to do the association rule mining. And then algorithms like the k-means, which is the clustering, used to do the cluster method, to do the clustering task, actually to find the based on the defined number of keys in the data, then it will calculate the mean average. Then from there, it will tell us the similarities between the data. We will see all how this can be done using the data mining techniques. And then also today we are into neural network. Neural network is being used also to establish, to do the classification, which especially when we are dealing with the big data, or we need to go deep into the data and then understand the concepts. Okay, so then it will neural network is used to do that, actually based on the network of the layers. Then today, actually, it has even transformed into what is called deep learning. So deep learning uses neural networks algorithms. This is what we call artificial neural networks. So it is trying to mimic how the human brain is working, how the connections in the human brain, neurons in the human brain are working. Then it simulates that, and then comes with the algorithms that come. That is very powerful enough to solve the problem. And then also naive Bayes, which is another algorithm, then k-nearest neighbor. And then also statistical method can be used to do the data mining. because actually traditionally we can use statistical methods. As we said earlier, I think last two we have discussed it. Data mining actually is a subset of all this, especially the statistics, the AI, and the machine learning. So statistical methods are there, and then they can be used to do the data mining. So these are some of the tasks. There are a lot of tasks today that can be done, and then there are so many techniques that can be applied to do the data mine. So let's take them one by one and see what we mean by all these tasks, and then how these tasks can be applied to do the data mining. So let's start with the classification. When we say classification, we have the collection of records, as I've given you example in the lab, what we call the training set. So this record actually is divided into training and testing set. So each record contains a set of attributes. One of the attributes is the class. So I took time in the lab to show you this is a class. So now you see why we are taking that time to explain all these kind of terminologies. So now we know what attributes means in the data and then what the class means. So in each data, there should be a class. This is why it's called classification, because the data is classified based on the class values. For example, the data set that we use this week, like the weather data, the class is play. So all these are the remaining attributes, the outlook, the temperature, the humidity, the windy, is trying to help us to classify those class values. That is what? Play, yes or no, play or not play. So that is what is called a class. So in a given collection of records, when you have the records, that is the data that can be used to train the model. So each of these records contains a set of attributes. These attributes actually, one of them must be a class attribute. And then we try to find a model for class attribute as a function of the values of other attributes. For example, we are trying to find whether we can play, whether the play is yes or no, based on the functions, based on the actions of the other attributes like temperature. Yeah, the temperature is 90 degrees Celsius. So the class is saying no, because weak as it's not recommended to go and play at under the 90 degrees Celsius. Or the humidity is high, for example, so it's not recommended to go and play under that. Or it is windy. So these functions of that particular, or any of the attributes there, is what determine actually the model, what help the model to do the classification. So we have the model for this class attributes as a function of these values of this attribute is what we call the classification, trying to find the classes. So this is what the model is doing. So the goal of doing the classification is to look at the previously unseen records, which should be assigned a class as accurately as possible. Now we train the model based on the available data. Okay, now the model is aware. Now understand the rules. If this happens, then the class is going to be no. Or based on this and this, the class is going to be no. Temperature is high, it is windy outside, then it is telling us no, don't play outside. So now, this is what is meant by previously answered. Previously answered that, okay, now when you train the model, then you take the data that has no class value, trying to test that model, say, okay, now, can this model actually give us an accurate result? Now, the class has no value, no yes and no, but we want the model to use that previous information or previous knowledge that it has based on the training that we have given to it using the training sets. Now to use minimum percentage of the test data to test whether the model can give us an accurate result. This is what we call a test set. So in doing the classification, the data is split into two, which we will see when we come to do the classification in the lab. Split it into two, let's say 70-30. 70, which is the highest proportion of the data, is used for training the model. And then the 30% of the remaining 30% of the data, which is a low proportion, is used for what? For testing the model. So sometimes actually always we need to train the model with what? With the high proportion of the data, because we need our model to have more knowledge. This is why as human beings, we always get knowledge until we die. So that knowledge actually is what we have. So the training is you are giving the model the knowledge based on the rules of if and then rules. If this happens, then this will happen. Then the model will understand the rule. So whenever a new data which is similar, has similar attributes to that data that you use for training, then it will understand it to tell you this is what is called a machine learning. So in machine learning, you are trying to train the machine. Then at the end of the day, the machine will do the work for you. So whatever the machine will do, this is why we have to develop the model to do that. This is why most of the machine learning algorithms actually are what? Problem specific, because they are trying to address a particular problem by supplying that data, the data that is what? Related to that problem. So a test set is used to determine the accuracy of the model. This is why actually we say we use the low proportion of the data. And after the training, the test set will help us to know, okay, whether this model can do the right thing that we want it to do. This is what we call the accuracy, whether the model can produce the accurate result. So usually the given data set is divided into training and testing set. Whose training set used to build the model and testing is to validate the model, because by evaluating the accuracy, you are trying to validate whether the model can do what is expected. So this is the classification. Bear in mind that when you have the data, and then the data has the attributes, and then one of the attributes is specified to be a class, and you train the data, the model, create the model using that data, and then test it with the remaining proportion of the data. This is what we call classification. We call the class, then we try to classify the data based on the attribute values. So this is a classification. So example of the classification is simple. You look at this data set. We have about 4 main attributes in this data. 2 categorical, 1 continuous, which is numeric, and then the last one is level as a class. So the first attribute in serial number 1 or ID number 1, we say, okay, yes, respond. That is what will determine either the cheat is yes or no. It's either the refund, the marital status, or the taxable income. Okay, so now we will look at the left-hand side. You have another data set without the class values. That's what I'm trying to say. So the big table here with 10 inputs is what we call the training data. And then another table with what? With only few input, which is like 6 inputs, is what we call the test data. So the big table is the data that is used to train the model. And then the small table is the data that can be used to test or to evaluate whether this data can give us the accurate result based on the similarity. But the attribute must be the same, but the values of the attribute also has to be the same. But if it's number, the number may be different, but actually the attribute has to be similar attribute. So this is why you see that, okay, refund, marital status, taxable income, and then cheat is also there. So now, using this small table as a data, the data in the small table here is trying to evaluate what the model has been used, can do when it is trained with the data in the big table with 10 input value, 10 instances, or 10 objects, or 10 records. So now, what we have here down is the model of the classification. This is a process. First is to use the training set or the training data. Then learn the classifier. Which classifier? The techniques that we have discussed in the previous slides. Any of the algorithm, maybe one of the algorithms in the decision trees algorithm, like J48, any other algorithm is being used as a learned classifier. This is why we call it classifier. If you remember, in our lab, we say, okay, when we say classifier, we are referring to the algorithm. So now, the algorithm is applied to the training data to develop the model. So now it will learn. This is why I call it learn classifier. The model will learn from the data. What the add was the technique of the algorithm. So different algorithms have different training method. But at the end of the day, the aim is to produce a model. So now the model is being tested with the data in this small table. So this is a process flow of classification. This is an example, simple and the layman example of how the classification process is working. So the data, which is called training data, is given to the system, which is what going to be used to train the model with any of the classifier. Then finally test the model with the test data, maybe based on the proportion of the split of the data. So when we come to the class, we will see how this can be applied practically, and then how we can do this classification using the Wika. So where can we apply the classification? As an introduction, we can apply classification in direct marketing. Actually, you want to reduce cost of mailing by targeting a set of consumers or customers likely to buy a new cell phone product, for example. It's just an example. So you can classify your customers when you have a record of customers. You have many customers, 1,000 customers in your that are buying your product. Now a new product is coming. So how will you target the customers that can buy the product? It's not necessary to say that you have to send email to all the customers that you have. No, maybe you can classify them based on their purchase behavior. Maybe the customers that are spending more money or the customers that always buy new phones if it is coming. So you can have the record because everything is there recorded. Now you can use a particular variable to say, oh, now we want to classify them based on this variable. Then you make it to be a class. Maybe the customers that always come and buy the new product. So now you can target them and then you send the email. So now we now collect various demographic data, the data like the lifestyle, as I said earlier, the lifestyle of buying the new phone whenever there is new phone. Like now, most of the people that are using iPhone, usually they change the phone immediately the new product or new one is coming. So that is a lifestyle. So now based on that, you can classify the customers. And then also the company interaction related to information like type of business. Okay, now so start interacting with your business, your company, what is their business is. Based on their business, then you can classify them based on that. Whenever there is product which is related to their business, then you can easily use the data to email them, to mail them, instead of wasting your bandwidth and sending mail to everyone. Okay, or how much they earn. That is, as I said earlier, based on their income. Then you can also classify customers based on their income. So, okay, now this product has a high price, so actually you don't need to send it to all the customers based on their income. So all this, and then identify which customer decided to buy and then which one decided otherwise not to buy. So finally, you can create a class to say buy or don't buy. That is a decision to form the class attributes. So based on these attributes, like the lifestyle, type of business and others, then can determine which of the customer can buy and which one cannot buy your product. This is a decision which is called a class attribute, which is the outcome of the classification. So this information can be used to as an input attribute to learn classifier model. So okay, that is to what? To train the model to do this classification for you based on this characteristics, based on these variables. Okay, which consumer can buy or cannot buy or don't buy our new products. That is the example. So another area of application is the customer attrition or customer churn. That is to predict whether a customer is likely to be lost or a competitor. Even last semester, I think one student used some students use do their project based on the customer attrition. That is customer churn, because there are available data that do this. So the goal is to predict whether the customer is likely to be lost to a competitor. Maybe you are doing a business and you have a lot of competitors, and then actually you have to work a lot and find out whether you can lose a customer or not. This is what the businesses are doing. So by doing that, then you can classify, use a detailed record of transactions, the past and the present transactions, and then how often the customer calls, where he calls, what time of the day he calls most, his financial status, marital status, and so on. So all this can give you information on whether your customer is still loyal or a disloyal customer. So this is the class, whether to be loyal or disloyal. So based on the data that you have about the customer, about the time he is calling the company, about the interaction with the company, about his marital status, about his financial status, then you can easily find out that whether you can lose this customer or you cannot lose the customer. Maybe your company is in Shalom, and looking at the marital status, he has now maybe migrated from single to married, and then maybe he moved to another location. So actually, he may likely not visit your shop. So this is what it is. All his financial status now changes actually. Maybe he has lost his job or whatever. Now he don't earn a lot of money that will make him to come to your. So all this can help you to understand whether your customer is still loyal or is disloyal to your business or your company. So this model actually can help you to find a model for loyalty. That is a target. So this is how the classification is being applied to what? To solve a lot of problems. So as an overview, classification in data mining is just a technique used to assign labels. This is why we say it is supervised learning method, because in supervised learning method, we do have what is called data label. That data label is what we call class variable. That class variable is what will have the objects or class values that can help you to label the data based on what? The class, based on the class values. So classification in data mining is just a technique which uses to assign labels or classify each instance record or data object. As I said earlier, you can call it instance, you can call it record, you can call it data object. All this is the name that we are given to data instances. So in a data set based on their features or attributes. So based on the features, we'll determine which customer is loyal, which customer is disloyal, which one will buy, which one don't buy. So all this, then based on the class, we determine when to go and play in our wizard data set or when to not play. So all this is what we call levels or classify or labels, or either level or classify the instances. So the objective of the classification approach is to predict class level of new unseen data accurately. As we have seen in the previous slide, we train the data, we use the test data. This test data have the unseen levels. Then we are trying to what? To see whether the model can predict, because there is no level now in the unseen data, but the model already has knowledge about the data variables. So now based on that, he developed the rules. That rules is what we call the model. The rules that make the model to be a model. Then try to see whether this can predict that class levels, to say, okay, now based on this, the model is predicting that class level to be no, or is predicting that class level to be yes, or is predicting that class level to be loyal, or it is predicting that class level to be disloyal based on the understanding of the data, or buy or not buy or don't buy. So all these are the class levels that call what is called unseen data, that is trying to predict the class level of the new data accurately. So now you look at this diagram, it's summarizing training data, do the data mining system, then develop the model. The model can do the prediction using the new data on top there. So the model is trained within the available data. So the data mining system is here. This is where we are working around, how the model mining system can work using the particular algorithm. Then the model is developed based on the training using the data mining technique. Then you supply the new data, then which is unseen data, and then see whether the model can do the prediction accurately. This is a classification. So in a nutshell, this is what we mean by classification. So in contrast to the clustering, actually, take note when we say classification, as I always say, we are referring to the supervised method where there is data labeling. to be classified data levels. And then in clustering, actually, there is no data level. This is the difference. This is why clustering method falls into unsupervised learning method, where just the similarity or the distances between the data can be established and then form the group of data. So giving a set of data points, actually you have each having a set of attributes and the similarity measures among them, because clustering always work with what is called a similarity measure. We will come to see them when we come to discuss them in detail, maybe in the subsequent weeks, like the Euclidean distance, Matan distance. All these are the distance functions that are available. They help us find the data points in one cluster which are more similar to one another. So clustering is trying to find out what is called intercluster and the intra-cluster similarities. Intercluster, that is to establish the relationship between the data points that are more similar within a particular cluster. That is intra-cluster, inside the cluster. Intercluster, that is the distances between the cluster number 1 and cluster number 2. So clustering is trying to group the data. Grouping that data is what you call a clustering, to form a cluster. Like in the class, now you can form a cluster based on the arrangement of your tables in the laboratory, based on the arrangement of your desks. Then you can form your clusters. You have 2 clusters, 3 clusters, 4, depending on the size. Maybe cluster of 5 people. That is the group. So this is what the clustering method is trying to do. Now you have the data about the business. You are trying to group the what? Based on the similarity of relationship of those customers, and their similarities, and you group them into one cluster. Okay, these customers, all of them are international customers. So you group them into what? One cluster based on that distance function. So it is not using any class, but it is trying to look at the particular attributes. What are the what? These data points in one cluster are more similar to one another based on what? Maybe the attribute called international. So if they are all international, they are grouped into one group. All customers that actually always buy new products. Now you can use clustering to cluster them in one cluster. So whenever you want to reach out to them for marketing or whatever, you can target those groups. So similarity measures is used, like the Euclidean distance, if the attributes are continuous. That is, if the attributes are numbers sometimes and discrete values. Other problem-specific measures also use if the attributes are not continuous values. So we'll see in the discussion how clustering is working. So now this is what I have been discussing: intra-cluster and then intercluster similarity. So you see what we have here as red colors in the left-hand side. These 7 points are trying to say that they are closer. So this is what we call intra-cluster distances. So finally, we have distances between them. So what is the distance between this dot number 1 and dot 2? You have the 7 dots here, or 7 points. Let's say we call them data points. These 7 data points form one cluster. This is why they are red in color in this diagram. And then another group of blue also form another cluster. Another group here of maybe purple make another cluster. So in this particular cluster diagram, we have what? We have 3 clusters. Okay, so intercluster similarity or distances are always minimized. They are always minimal because the distance between this data point is very close compared to the distance between one of the red color here to one of the blue. So the distance between one of the red color here, red point, to one of the blue point, whether it is closer one, this is what we call intercluster distance, which is always maximized. This is always maximum. So this is the difference between the 2 different clusters, while the intracluster, between the data points that are in the same cluster. So this is how actually the Euclidean distance-based clustering is working to identify how the clustering can be done to group the data based on what? Based on the data point distances. So if the distances are closer, then they will be grouped. This is why algorithms like k-means is used. First of all, it will calculate the mean average of the data. Then based on the mean, if you want three clusters, so okay, k equals to 3. That means you need 3 different mean. So based on this, any algorithm or any data point that is closer to that one of the means, then it will go closer to that mean. That means it is in that group. So it is analogous to say that, okay, now you want to form a group in the class, you point out the class representatives. Maybe you have 3 groups, like in this class, we have 3 or 4 groups, or even 5 groups. Now each cluster will just turn off. Then we say, okay, now anyone in group A, just go closer to the class rep of A. So that is how we can easily group people. Okay, now everyone now, for example, has his own group from the portal, but we didn't know each other. But when we meet in the class, say, okay, now the class reps should stand off. Class ref of class of number of group A, group B, group C, group D. All 4. Okay, now say, okay, group A, then all of you, all those in group A will just go closer to the class rep of group A. So that means they have what is called what? Closer, or they have similarities in common because they are from the same group. That makes them to be in a common group. So class rep or B, okay, now all those that are in group B, just go to the group B class rep. That means because they have something in common which make them to be in one group. So that is how the distance functions actually works, to show us how the clustering is working. So clustering applications, one of the areas of application is market segmentation. The goal of market segmentation is to subdivide a market into distinct subset of customers, where any subset may conceivably be selected as a market target to be reached with a distinct marketing mix. Yes, you need to do the marketing, then you subdivide your customers or market into distinct subsets of customers. So whenever you are targeting a particular group, then you say, okay, now maybe you can do it based on the age group. Say, okay, now I group my customers based on their age. This is the young age, this is the senior age, and then this is the old age. So based on that, you know that, okay, this product actually is for the young age. So I will target, the company shop will just target the customers that are in that group of age. So this is how the customer segmentation is being done, or market segmentation, so that can be used to do that. So the approach is that collect different attributes of customers based on their geographical and lifestyle related information. Once you have this information, this is the data that you have, then find clusters of similar customers. As I said, maybe based on the age, based on their location, based on this, then you have the different groups. And then measure the clustering quality by observing buying patterns of customers in same clusters versus those from different clusters. So this is how the clustering is being formed. So from there, then you can easily understand the learning pattern. What their priority in buying, then you understand how you can easily reach out to the customers. So clustering is simply to group customers into different segments or different groups. So this is a market segmentation. Segmentation 1, high duration but low number of generated calls and moderated number of sent and received SMS. So you can see this colors is trying to show how the market is segmented. 1, 2, 3, 4, 5, up to 6. Or 6 different segments based on the distances, based on the similarities of the customers. So now the market is divided into 6. And then the segment number 2 is those that are calling moderately, with a moderate duration calls, and the other moderate to high data usage. Segment 3, those that have high duration of net calls. So now company is trying to say, okay, which of the customers are trying to communicate with our company? So based on this priority, they try to segment them. Those with a high, those with a low, those with the low of net calls, so very low calls, very low calls, very low data usage. All this can help to understand the behavior of the customers. So finally, if you are targeting the group 1, then you target group 1. If you are targeting group 4, then you know you have this number of customers that are in this group 4. They have their recall duration. So maybe you can do some marketing to bring them back to your business, because you always need customers. So another application is document classification clustering, which we will also explain it in detail. Maybe we'll do some calculations on how document classification is working. So the goal is to find groups of documents that are similar to each other based on the important terms appearing in them. So the approach is to identify frequent occurring terms in each document, form a similarity measure based on the frequencies of different terms, use it to cluster, then gain information retrieval can utilize a cluster to relate a new document or search term to cluster document. So this is another application of clustering, where you can do what is called the document clustering. You have the document, even in your computer now, you can see that you can use folders to do the clustering. You have a folder called data mining, for example. You have all the documents inside that folder. You can also split the lecture into different folders. Say, okay, now this folder is for the practical lab, this one is for the lectures, this one is for the assignment, this one is for the tests. So all these are you are trying to segment the document. And also this is what is being done actually. This concept is being done nowadays it's being used to develop the similarity software systems, similarity checking system like the Turnitin and other systems. So they use document to cluster the documents. Okay, now this group of documents are similar to this document that is what being tested on this system. So these similarity checking systems actually that's plagiarism checkers. So actually use document clustering to group the document and then find out which these terms are closer to this. Then finally they will tell you the similarity is so percent. If the similarity is high, then it will tell you, because based on the approach, they are trying to identify frequently occurring terms. So based on the document you are given, you have done your assignment, then you are trying to check the similarity using any of the software. Then by sending it or by uploading it into the software, then it will look at the related terms based on the related terms that are frequently appear in your document. Then it will relate it to the outside document on the web. Then it will finally tell you this is where you get this document, and this is where you get this. So this is the concept of the clustering, which you make use of this technique to come up with a similarity checking system today to check the plagiarism and the rest. So the next task is the association rule discovery, where you can discover rules from the associated data. This is also another form of unsupervised learning method, because association rule actually is trying to find the relationship without the class level also. So once there is no class level, then it comes into unsupervised method. So when there is class level, so it falls into the supervised method. This is why we say regression analysis falls into supervised, because there is a class level in doing the regression, as we did in the lab this week. So now, if you have a given set of records, each of which contains some number of items from a given collection, to produce dependency rules which will predict occurrence of an item based on the occurrences of other items. This is association. As I said earlier, it is trying to establish the relationship between the data items. Okay, now let's give example with this market basket analysis that we always use to as a running example for association. You go to the supermarket, you buy different things, actually different items. So let's say this is a 5 customers. These are the 5 customers with different IDs. Customer number 1, 2, 3, 4, and 5. So the first customer bought 3 items: bread, Coke, and milk. Then he come to the counter, record his items, and then pay. The second customer, yes, bought just beer and bread. Then come to the counter, record and pay. The third customer, beer, Coke, diapha milk on this. And then first customer also buy beer, bread, diapha milk on this. Then the last customer bought Coke, diapha milk. So now, actually now based on these items, based on these purchases that we have, finally when you close down your shop, you can also do some analysis based on the purchases. So, okay, now we realize that some of the customers that bought milk also bought Coke. So how many customers have that? You look at the purchases. In which instance do you have Coke and milk at the same time? Maybe number one, there is Coke and milk. Number three, there is Coke and milk. And then maybe number five also, there is Coke and milk. So out of 5 transactions, we can say, okay, 3/4 transactions actually bought Coke and milk at the same time. So that is for one item set. For the 2 item set also, you can say, oh, what if customer buy diapha and milk? Does that imply that he bought beer? How many places do we have that? Maybe in the third customer bought diapha and milk, then at the same time he bought also beer. And then maybe first customer also bought diapha and milk and bought. So that means 2/4 of this, they bought diapha and milk, and then at the same time they bought beer. So that is how the association is trying to establish. So now, for example, now finally you say, okay, now based on what we have established here, 3/4 customers out of 5, and that means actually we can say about 60 or 70% of the customers bought Coke and milk at the same time. So now, if Coke is placed in a very far place from the milk, then the shop may decide to say, oh, let us arrange our shelves to say that, okay, now the Coke actually is closer to the shelf where we usually keep our bread, because most of the customers keep our milk, because one of the customers that bought Coke, they bought milk also. So maybe they are mixing it to use it. Or let's say bread and milk, for example. Some people are using milk to prepare their tea for bread, and then they are using bread also at the same time to use it for. So that means we are buying bread and milk. Okay, now since we have bread milk here, why not keep the bread closer to the milks so that when they put. So all this is trying to do to what? To ease your customers, to please the customers, make sure that okay, you use the data and improve your business. That is what is called association, trying to find the relationship between the data items. So here is an example of how the rule is discovered. Milk implies Coke. This is what we are trying to say. How many times milk implies Coke? So when we come to do the calculations, maybe you will see how all this can be established. So where can we apply association? Marketing and the sales promotions, yeah, because based on the relationship of the purchases, so most these customers that are buying this, okay, maybe they are buying milk and Coke at the same time, but nowadays you are the new product of Coke is coming, maybe no longer using the Coke, you are no longer selling the Coke in the shop, but you have a new drink which is can substitute Coke. So now you say, okay, now let us target those customers that are buying milk and Coke at the same time. So that we what? We advertise the new drink, which can substitute Coke. So that is how this we can apply this method to do the marketing and then to advertise our success promotion of the companies. So this is just an example with the potato chips as a consequent. We see that bagels implies potato chips. So this used to determine what should be done to boost the sales of one of the products. The bubbles in the antecedents can be used to see which product will be affected if the store discontinues to selling bagels. So based on the analysis, okay, now these are the number of customers that are buying bagels and potato chips. So now, actually, number of customers may be affected because when they come to buy, they realize that there is no bagels in the shop. So you have to target them and inform them maybe period to their coming or advertise the new product that can substitute the bagels. So this can be used to see what products should be sold with bagels to promote sales of potato chips. So what can substitute the bagels so that when they come to take the potato chips, they can also take that product. So this is how the marketing strategy is being used. And then also another application similar to the example I have given to you, supermarket shelf management. You can use this information to manage the supermarket shop. So the goal is to identify items that are bought together by sufficiently many customers. As I have given you example, out of 5 customers, 3 customers, 3/5 bought milk and coke. So now based on that, I can process the point of sale data collected with barcode scanners to find dependencies among items, because you have to come to the counter, they just scan and then they record the information. So from there, you can discover the rules. If a customer buys Jaffa and milk, then he is very likely to buy the beer. Or you don't be surprised you find 6 packs of beer stacked next to the Jaffa. So this is how they shop. This is why actually sometimes just wake up in the morning, go to the supermarket that you used to go and do the purchases, you find out that they arrange the shelf. This is what is called the shelf management. Based on the information, based on the record of their purchases, now they realize that they need to keep coke closer to the milk, or they need to keep bread closer to the milk, because many customers are interested in buying those items at the same time. So to save the time for customers, then they can use that. Also, retail analysis, you can use association rule mining to do what is called retail analysis, uses software to analyze data from diverse sales channels, revealing insights into customer behavior and trends, from identifying top selling products to refining market strategies. Retail analysis aids data-driven decision making. So this is an example where customer can be boost, customer boosting customer relationship and store revenue via retail analysis. So data mining actually can help us to do what is called retail analysis, to analyze the data from different sales channels. Maybe you have a shop that have different outlets, and then you have different customers. So now you understand the customer behavior, and then look at the trend of the purchases, and then finally establish the identify the selling the product, refining marketing strategy. So this is why I will always say the essence of doing the data mining is to help us to have a data-driven decision making. Based on the available data, we do the analysis, then finally we come up with the solution. And then also the regression analysis is used to predict value of a given continuous valued variable. I think with some groups, I think being yesterday, we try to generate the regression analysis with a simple linear regression. If you could remember our last meeting with some groups during our lab session. So regression analysis is trying to predict the value of a given continuous valued variable. When we say continuous, this is why yesterday I told you regression analysis is always being done with the continuous data or numeric data. So this is why we use humidity and temperature to find out the formula, to generate the formula for doing the regression based on the value of the variables. So this is what we call the regression. We're trying to find the dependency between different data, different continuous variables. So in simple linear regression, actually it uses only one variable to determine one independent variable to determine one dependent variable. So, but in multivariate analysis, then you can have different variables that may determine the dependent one. So this is correctly studied in statistics and machine learning fields, predicting the sales amount of new product based on the advertising expenditure. As I have given you example yesterday, we can predict the price of the houses based on what? Based on the number of rooms, based on the lot size, based on the toilet size, based on the kind of furniture, based on the items or equipment put in place in that house. All this can determine the price of the house. So this can be done to predict wind velocity as a function of temperature or humidity, air pressure, or we can do the regression to do the time series prediction of stock market indices. So for those stock brokers, they can also use regression to predict what will happen if this happens, then actually the market will go off. Then if this happens, then this is why even the company banks, like the central banks of the country, like the Nagara, they're always trying to predict the market of the dollar based on what is happening, maybe based on the crisis in the Middle East. They predict that okay, ringgit is going to be higher against the dollar. So this actually is always being used to predict what will happen. So this is the essence of the data mining. So trying to understand the data, predict, take decision. So if you are in the news, the Malaysian news, you will see that they are saying that by the mid of 2026, they are expecting dollar ringgit to get more strength over the US dollar because of some factors. So these are the variables that they use to say, okay, now this is what is going to happen. So this is very good insight. This is why actually data mining is very interesting. And today, most of the organization, almost all of the organization actually, especially those into the big businesses, they use data mining to do some predictions because it saves a lot in that organization. And then deviation analysis, as I'm giving you example, when you are to discover most significant changes in data from previously measured or normative values. As I have given you example, the normal flow is that, okay, now use your ATM card. When you put the ATM card in the machine, so the machine will read, and then the data is captured there based on the number of the card. That number of the card has to what? Be aligned. What must align with what? With your bank details, with your account number, with your maybe what you call it, your IC number, and the rest. So now, suddenly, the password actually is wrong. So this is a deviation, trying to find out, okay, this is the normal. Normally, when you used to insert the card, it will verify your ATM card, it will verify your account number. Yes, tick. Verify your IC number, tick. Okay, so to do all the verification, then wait for the password. Put the password correct? Yes, then it will allow you to do the transaction. Suddenly, the password is wrong. So this is a deviation from the normal. So when it has actually attempted 2-3 times, then the system of the bank would quickly block the card, suspecting that this card is stolen by someone which is not the owner, or is being used by someone which is also the owner. Either it is lost or it is stolen. So this is how the deviation analysis is. Actually, data mining helps us to do the deviation analysis. This is why most of the businesses have the systems in place. Even maybe university, if you are trying to connect the university internet, your ITM internet, with what? With without the official email. So definitely you may suspect something. Then the IT managers may suspect deviation from there. Why? Because we know that everyone that is connecting to our network must be our staff. Otherwise, he has to be registered as a guest. So you cannot connect to IP staff with different email. This is a deviation. So there are systems in place that are always trying to find out what is going on and what is happening actually in our systems. So usually, categorically separately from other data mining tasks. Yeah, sometimes we call deviation analysis, but actually it is a data mining task. Deviation are often infrequent. Modification of classifications, clustering, time series analysis can be used as a means to achieve the goal. So in doing the deviation analysis, sometimes we apply the classification techniques or clustering method. We call it a task, but we can apply or we do modify, because it is all about the classification, trying to classify the kind of information that is coming actually. So this is why even so now, and then also outlier detection is also the deviation analysis. All this explanation that I have given you is to finding the outliers, because what is happening, outlier always is outside the normal range. So we can use deviation analysis to find outliers in statistics. So we'll see how outlier can be detected even in the lab, because we will do it during our lab sessions. So outlier detection is also deviation, because this is a normal flow of the data. For example, now the data range is, let's say, 10, 20, 30, 40, 50 with the interval of 10, 10. So suddenly, instead of you after 50, you're supposed to see 60, then you see 110. Then continuously we see 70, 80 continuously. That 110 is what we call outlier because it is outside the red. When you plot it on a graph, you see it away because the interval of the data is 10, 10. So suddenly, instead of 70, 60, you see just 150 in your data entry. So this is why actually part of the pre-processing of the data is to detect the outlier and remove them from your data or replace them. So that is it. So the outlier is a deviation because it is a deviation from the normal. The interval of the data is 10, 20, 30, 10, 10 intervals. So suddenly we 150 appears. So that 150 is a deviation. It is deviation from the normal uh, data flow. So definitely we call it an outlier in statistics. So this is another tax of the data. So while we apply the anomaly deviation analysis, as I've given you example, anomaly detection, which happen actually in the credit card fraud detection, detects significant deviation from normal behavior. I have already given you this example. Someone want to use the card with different password, then the anomaly will be detected. Then they will record the deviation from the normal or network intrusion, as I have given you example with the UITM internet. So then managers will easily identify, okay, now which computer or who is using our internet through the window. That is an intrusion. So this is what is called intrusion detection. So trying to find out, so maybe some people are trying to intrude into the network and then maybe tamper with the data of the system of the organization, which is very critical. This is why today actually many of the computer science then go into the security, network security, network security. All that we do is trying to prevent the intrusion into the network. How can we prevent our system? How can we depend the system? How can we maintain the integrity of the system? Because actually affecting the intruding into the system may easily affect the integrity of the whole organization. So this is why it is serious. Actually, day in, day out, new algorithms are coming to make the security of the system very stronger to avoid the intrusion. So intrusion detection is also an anomaly detection, which is part of the deviation analysis. And then fraud detection also, as I have given you example. For example, I can easily identify fraud and especially those that are working in the financial institutions actually. So in fraud detection, actually, like the banks now can easily track they are tracking everyone that has account. So maybe this is they have your record and this is your monthly earning. Actually, every month you are getting 2,000 RM, but suddenly they sold 5,000, 6,000 coming to your account. So definitely they have to suspect something maybe is happening outside. Then where are you getting that amount of money? So identify employee account as financial institutions that have access numbers of credit memos. Access credit memos can indicate diversion of funds into employee accounts. So a lot of frauds have been detected due to that. Organizations like anti-corruption agencies are always working hand in hand with the banks, with the financial institutions to see whether they can detect fraud. Even the country to country, you see that frauds are being detected for those that are into money laundering and other activities. So this is another deviation analysis method. And then to compare employee home address, social security numbers, telephone numbers, and bank routing, and account numbers to those of vendors from vendor master's file. So the task can reveal improperly selected vendors account where they put that money. Okay, so you can see the Malaysia anti-fraud system operational. October, they found some frauds. So a lot of things, Malaysia plans insurance, fraud detection system. So a lot of systems now actually are using the fraud detection system. All these are the deviation analysis that help in data mining that help to find out, because a lot of money are being lost based on the frauds, especially nowadays actually there are cyber crimes that can that people use to do some frauds on the internet. So a lot of things actually are happening. So this is under some of the examples. And then also profit sharing cases is another deviation analysis, especially a profit sharing actually is about the making more profits in the business. So a lot of things, even so recently, you can see in 2024, nearly 25,000 premises checked for profit sharing. Actually, the businesses actually are trying to take advantage using maybe, and now we are going into the Deepavali holidays, or some shops, maybe the shop suddenly decided to increase the profit, the prices. So they increase the price for only 1 week. So within that period of time, they can make a lot of money. So that is what these agencies that are controlling price in the countries are trying to detect. What is happening to this? This bottle of water is being sold 1 RM. So suddenly, because of we are into the holiday, so they use that advantage to increase it to 1.2 cent. So within that 1 week, they can make a lot of money. They can make big money. This is what is called profit sharing. It is deviated from the normal price. The normal price is 1 RM, but now suddenly we go to a particular show, we bought it 1.2. People don't even understand it, maybe because it is something that you don't even care. But for them, they make a lot of money within a short period of time. So agencies that are controlling the price in the country sometimes are checking on this actually in their system. They see the flow. So why this is being sold this? So sometimes they invite the business people, managers, to explain why this price is high, why this is what is called profiteering. Actually, they are trying to make more profit within a short period of time. So some people in the businesses are very smart like that. They use 1 week, 2 weeks to make some profits and then go back to the normal. This is a deviation. So when the system actually, when the agencies check, they will see, oh, within this week, why these prices went off in this business. So they will check, they will find out that there is what is called profiteer. So a lot of cases have been reported. So these are the kind of deviation analysis. This deviation analysis helps us actually to find out all these cases. So all these agencies are using deviation analysis to find the deviation from the normal anomaly, or finds anomaly from the normal flow of the business. So you read this, you can see the cases, you can even find out more online. You can see a lot of cases that is been happening in many countries. Okay, so any question, please? Almost 1 hour talking. You have any question?
So far, no, sir.
Okay, so far no question. So let me give you 5 minutes to rest and we'll continue with the last part. I think it's not too much, only nine slides. So we'll be back at 4:23, right?
Okay.
Okay.
Okay, sir.
Yes, you want to ask question?
Sir, can I ask a question?
Hmm? Go ahead.
Uh, so in data mining, uh, data mining only for fraud detection or security purposes, or is there any other example, any other types of system?
Yeah, this is why we have given you example right from the tax of classification. I think I have given you example. If you refer back to the slides, I've given you example of what data mining can be done in doing the classification, like the customer classification to classify the customers for marketing, for example, for promotions. Then you use clustering also to group the customers into different groups so that you can target them. Giving you a lot of examples, and then also for association. And
Oh,
I'll go
okay.
to the. I have given you a lot of examples. This one, the one that we have given you, I've given you for fraud detection, is about the deviation analysis under the deviation methods, right?
Oh, I see. I see.
Yeah.
All right. Thank you, sir.
Okay, you're welcome. Okay. So the last part of the introduction. Are you back?
Yes.
Okay.
Yes, sir.
Okay, so the last part, we are going to discuss some problems and challenges of data mining. Now we have seen some tags, techniques, and then the application. So subsequently, we'll be discussing these tags one by one, that the classification, clustering, association, and continuously up to the recent trends. So what problems actually does data mining have? This is what constitutes this last part of the introduction material. So some of the problems is actually always, as far as data mining is concerned, we are battling with the efficiency and the scalability of the data mining algorithms. So these algorithms are trying to see that we have the algorithms that have, can produce or can do the mining actually in a very short period of time, that is with high efficiency, and then also scalable to the data, because data is always growing. So as data is becoming big, so we need algorithms that can scale to the amount of data. So this is one of the challenges. So this is why actually for those of you who are interested in doing data science, and then you think of how to come up with algorithms that are scalable in nature. So you have the algorithm now. What if you test it with this so amount of data? What if the data is increased? So that does algorithm scale to this data? This is what we mean by efficiency, API scalability. And then also efficiency is we are referring to the time taken to produce the result to give us the outcome. And then parallel and distributed stream and incremental mining method. This is another method. We can have parallel method or distributed methods, as we have the distributed systems today. So how can we do the data mining in a parallel mode? And then handling high dimensionality, when we have the high dimensional data with different dimensions, then how can we have the algorithms that can handle that? It's another challenge that need to be worked. So the essence of presenting these challenges to you is as a student, then you can think of, okay, now what can I do to improve so algorithm? And then also handling noise, uncertainty, and the incompleteness of data, because definitely whenever you are doing data mining, you must be faced with some missing data, which actually we are going to see how we can do the pre-processing to remove the missing data in the lab. So handling this actually is another form of method, so that we can have algorithms that can easily handle missing values or missing data or noisy data that is inside the data whenever we are training the model. And then also the uncertainty in the data, because sometimes you can have some data values that are uncertain. How can we have the algorithm that can do that? And then also the incompleteness of data, which is similar to the missing values. If the data is not complete, so how the algorithm can act on this particular data. And then incorporation of constraints, especially when we want to optimize a certain algorithm. So how can we incorporate some certain constraints? Because optimization always go with our constraints, the limitations that can control the optimization algorithm. So now this one is also another way. And then also expert knowledge. How can expert and background knowledge be integrated in the algorithm? Is another way forward to actually data mining improvement. And then pattern evaluation and knowledge integration. How does the pattern be evaluated? Because now we evaluate the accuracy, we validate the model. So how can we evaluate the pattern by pattern? How can we evaluate that pattern that can give us the knowledge? And then how can we integrate that knowledge into the decision? So also is another challenge. And then also mining a diverse and heterogeneous kind of data when the data actually is set, because sometimes data mining always works with the homogeneous data where you have it's not diverse. So when you have a diverse data, so how can the data mining algorithm work with that data? So these are some of the challenges that actually, as a student, as a lecturers, as a scientists, we need to also look at them one by one to see in what particular point we can improve the performance of the algorithm. That is the one. And then also with regard to comparing data mining models, then we need to also find we have a challenge in the performance issues where we can actually how we can compare the performance of the model, especially what can we use to check the performance of the model. Now we say, okay, now we measure the accuracy. This is only the accuracy that it matters in this? Maybe no. So one of the performance issues is cost of learning set, number of examples necessary for training, and then cost of assuring the good accuracy. This is another challenge. How actually necessary training data can be used, then how much time will it take to train the model? This is the cost. So for us to have an efficient model, then we need to consider the time cost of training the model, and then also how this model, this cost of the time can ensure a good accuracy, because it has to be balanced between the accuracy and then time taken to generate to train the model. And then time and memory constraints, actually time complexity of the learning pace, time taken for evaluation, of course, is another thing. Time it takes to reach a certain level of accuracy. Yes, they're measuring the quality of accuracy of rules. So all these actually are the way that we can, are the issues that are related to the performance of data mining, which are actually, you can look at it and think of improving. And then predict availability, to be able to predict the correct decision toward the test or unseen data. And then involve the generation of rules, because as I said earlier, the model is trying to generate rules. So how can this generation of rules involve correct decision toward the test or unseen data? Because in the training, it generates rules. So now, what if we give it the unseen data? Can this be incorporated into the model during the testing? So that is another way. So these are the performance issues that can be studied. And the another one is robustness. How robust the model is, that is ability to cope with errors, because actually maybe the model actually can have some certain errors. We can see in the evaluation the kind of errors that are associated to the model when we develop the model. So how does the algorithm actually cope with the errors, and how does it influence the noise? What is the influence of the noise in developing the model? And then what is the influence of the outliers in developing the model? If the model has some noises, then the unwanted data or missing data or some outliers, then Can this model be robust enough to handle all this? That is another issue. And then, as we said earlier, the scalability, that is the ability to cope with the big data. So we need algorithms that are scalable. And then interpretability, how does the model interpret? Especially nowadays, we are into what is called explainable AI. So how can this be incorporated to interpret the result, interpret the prediction result of the model? This is another way. This is why now you will see some students are doing data mining, then with the machine learning, and then incorporate explainable AI. This explainable AI can help us to do the explanation of the decision of the what of the outcome. Not only to get the outcome, but now get the outcome, then to also the model will also explain the outcome. So integrating explainable AI can address this issue actually to have more explanation about the model and then how to ensure the transparency of that model. So these are some of the areas. So how do you value data? Value data when you notice it as of scholar. So you can read that Malay language and you can understand what we mean. Actually, this is how we see why I always say data is very important. You can see all these worlds that you are seeing, the map of the world, you can see data. From this type, from the seas to the land, all these are the data. 2014 to 2016, actually MH370 loses. When we miss that airline, the whole world actually uh, were in very terrible situation because the whole airline, and maybe you have the information about it, the Malaysian airline MH370. So up to now, we are always thinking about it because we lost value. This is what we are trying to say. When you lost people, especially a lot of scholars that died in that, then we know that okay, this is the value of the data. Because once you miss it, then definitely you know this is you know the value, understand the value. So life resources actually has been lost because we lost the airline. Then definitely since that time, a lot of life has been lost in the airline. A lot of resources right from the airline itself, resources used to monitor, to do that, to check it, do a lot of things, searching process, all these are the lost. So this is how we value the data and knowledge actually. So in conclusion, the summary of the introductory part, we have introduced you to the data mining, that is discovering interesting pattern from the large amount of data, which is, and we refer data mining as a natural evolution of data-based technology in great demand with wide applications in business, in medical, in manufacturing, in health, in education, everywhere you can think of applying data mining. So KDD, which is knowledge discovery in databases, is a process which includes data cleaning, data integration, and data selection. So all these processes involve this. Then transform the data, perform the data mining, and then evaluate the pattern, and then present the knowledge which is going to be used, or is always used for decision making. Then we also mentioned to explain how data mining tasks are. We say mining can be performed in a variety of information repositories, and then we can do classification, clustering, association, deviation analysis, which is anomaly detection, and then a lot of like the regression analysis, uh, cartel analysis, and the rest. So all these are the data mining tasks, which uses data mining techniques like the decision tree, k-means algorithm for doing clustering, decision tree for classification, a Ferrier algorithm for doing association rule mining, and a lot of algorithms that can be applied as a technique for data mining. Then finally, we discuss some major issues in data mining, which some of them are the scalability, high dimensionality, heterogeneous and complex data, which is very important issues that need to be looked into when as far as the data mining is concerned. So I think that is the end of the introduction, which is the topic 1. Based on the lesson plan, it is designed to finish this week. That is week 1 and week 2. So next week, we are moving into the data understanding, where we can discuss the real understanding of the data before we start doing the following the tasks one by one. So do you have any question to ask? We still have time, about 25 minutes. You want to ask question, please? Hello?
So far, no, sir.
Okay, so no question, well understood. Okay, so if you don't have any question, I think we can close here. So it's already Friday, Monday is going to be a break. Maybe you want to travel, or you have already traveled. Also, you stay closer, definitely I know they will travel home. So inshallah, we'll stop here. Next week, we'll continue with the next topic. And then also with the next level of exercise in the lab. So if we don't have any question now, we can call it a day. We'll meet inshallah same time, same venue for the continuation of the class. Thank you for having your time. Make sure you sign your attendance in your feature. Right?
Okay.
Okay.
Thank you, Dr.
Thank you.
So Jamaat Karim, Jumal Mubarak.
Thank you, sir.
Thank you, sir.
Thank you, Doctor. Thank you,
Thank you, sir.
Um,
Thank you, Doctor.